Alright, finding square roots. We could also say evaluate. We could also say simplify. Okay, so find negative square root of 49 over 64. To make this stand out, let's rewrite this. And I'll put a negative out front in purple just so that you know that that is in front of the radical. I'll make the radical in black. But to be clear, all of 49 and the 64 are inside of that radical as a fraction. And if I sidestep, you've done these in the past, and you know that 3 squared is 9, which means that, 3 times 3 is 9. So if I want to take the square root of 9, I'm asking myself what number times itself would give me 9, and well, that would be 3. So let's pretend instead of having something more complicated like we have, we just had the square root of 49. What number times itself gives us 49? Well, that would be 7. And then looking in the denominator of the fraction, what number times itself would give us 64? And that number would be 8. And the reason that I point this out is that as I do these one-step problems, it's okay to throw an equal sign and just move to the right. I'm looking as deep inside of my parentheses, or in this case, my grouping symbols, which is the radical, and I'm saying, well, what do I see in there? Well, I see 49 over 64. And if I picture some fraction being multiplied by itself, when I would get 49 over 64, and I'll be very clear in my explanation of this. I'll have some number up top and below, so those are both empty spaces to hold fractions. And then I've shown a times symbol there. So what I'm saying is some mystery number times another mystery, that same mystery number will give me 49 over 64. Well, when we multiply fractions, we just multiply right across. Well, 7 times 7 is going to give me 49. And I know you're probably thinking I'm explaining this a second time, but I'm providing a different visual. Well, and then I look at my denominators, and 8 times 8 gives me 64. So it's pretty clear to me that when I go and I evaluate this square root, I will get 7 over 8. But outside of that square root, there was a negative symbol. So that doesn't just disappear. So as my final answer, I'll attach the negative to the 7. And we've discussed how that's the most conventional way to show a negative, is to write it in the numerator. I have completely simplified my problem. Okay, now it says find positive or negative square root of 1.21. Now I see the value of 121, and I immediately think to myself, okay, that's 11 times 11. So I know this has to be something involving a 1 and then another 1. But the issue is, how do I deal with the decimals? And I want to avoid using my calculator to think about this. Well, 11 times 11 is 121. But what if instead I was like, well, maybe it's 0.11 times 0.11. Well, I know that 121 would be involved again, but I would have 1, 2, 3, 4 decimal points. So I would have to go back 1, 2, 3, and then 4. And this section is not called decimals. So this section would have to assume that you're pretty comfortable with decimals. So I'm showing this, but not expecting this video to go back and review all that. Well, that's incorrect because 0.0121 is not our target. So on purpose, I had tried it kind of in an outrageous example back here. I'm not going to try 1 here and 1 inside there, because that would be 0.11, while the other one would be 1.1. Those are two different numbers. So let's try it with 1.1 times 1.1. Well, there's a decimal here. There's another one here, so that's 2 digits. So I would go backwards 1, 2. And that means that I've checked this out, and I've ended up with what I began with. Yeah, of course, you could just use a calculator on these, but that's not the purpose of this. You want to think a little bit more deeply about these. So I'm checking that also. If I know the square root, I know that I could check these by doing 1.1 times 1.1. And if you prefer the vertical look, there you go. Now, if I just leave it as it is, I can't really be saying I'm totally done and boxing it. And that's because outside of this, this symbol means positive or negative. So I'm either dealing with a positive or negative, so I'd have to show a plus sign above a minus and then box it. So when I find this, I'm simplifying it to say 1.1. And here, by the way, this is definitely going to be the more conventional way to represent this. You should not write negative or positive. The only time you would ever do this is if it were part of a formula. So those are just a couple of examples of these, and those are the more difficult ones. Some of them are going to be straightforward. Okay, so compare real numbers. Compare using less than, greater than, or equal, so that's OR right here. So less than, greater than, or equal, to make each sentence true. So I see a square root of 19 first. In the book, they'll give you like a little circle or something. What they mean is you're just going to leave a blank here for a moment. So there's square root of 19, and then I have 3.8 with a bar repeating. A lot of you might be able to do this in your head, but I know I'm taking the square root of 19, and the square root of 16 gives me 4. Well, I can see that 16 is less than 19, so this value has to be greater than 4. But if I wanted to go on the other side, square root of 25 would give me 5. So I know that this value is between 4 and 5. And even if it's outrageously on the lower end, that is still larger than 3 and 9/10 once I round that up. So I'm going to say square root of 19 is greater than 3.8. And if you're unsure on these, you can use Wolfram Alpha, you can use your calculator, you can use a lot of the different resources to test this out. So same deal here, 7.2 repeating, it's what they show us. In the book, it would probably have an open area or some sort of symbol there. And then the square root of 52 on the right. And my choices are less than, greater than, or equal to. All right. Now, we've got a little bit of an issue here, and that issue is that this is pretty darn close to 49. And the reason I say 49 is because the square root of 49 is exactly 7. But it's also far away from square root of 64, which would bring me closer to 8. And so when I'm comparing something this close, maybe it's time to get a calculator out to figure that out. But let's say you left it at home. You left it at home. Your life is filled with great regret. So here's me taking something like 7.2. What happens when I multiply 7.2 and 7.2? Well, got to go the old school way, right? 2 times 2 is 4. 2 times 7 is 14. Drop a 0 here, and you get 7 times 2 is 14. 7 times 7 is 49. And 1 gives you 50. 5, whoa, that's ugly. 5144. And let's see, that doesn't really help us. That's dreadful because that's 51.44, which is shy of 52. So it looks like this is definitely a calculator deal. So if you were to keep going back further and further, you could get closer and closer, but man, that's going to be a pain. Alright, so that was some time eaten up that you'll never get back in your life, and I apologize for that, but I think it's a good example. So in your calculator, let's type in square root of 52, and this would be like side work, you know, like so maybe over to the side I put square root of 52, and then when I type it into my calculator I get 7.21110, and it's going to keep on going with some sort of irregular, no pattern. And when I compare those two numbers, I can see that this 7.2 would be 2, 2, 2. And if I were to stack them on top of each other, this value would be a tad bit larger. So yeah, bring your calculator to class, especially on an assessment day. Order the following from least to greatest. Now, -3, 0, 5, 3 halves. It's always nice to start with extremes, and here's what I mean by that. Well, what's the largest number I just wrote? Well, there's 5. So if I start with the extremes, I push that to the right. What's the most outrageous left number? Well, negative 3. And the reason I bring that up is that usually makes dropping the other ones in less intimidating. So it makes the decisions less complicated. So order the following from least to greatest. If this were a 5-point problem and you went from greatest to least, you would not get full credit. You would get 4 out of 5 points most likely. Okay, so let's look at the extremes. Negative 53 over 20, negative square root of 7. Those are both the negatives. Looks like these are going to require a little extra work. Let's keep them all comparable. Let's keep them all in decimals. So here's 2.63 just being rewritten. Now I'm going to type the square root of 7 in. When I type these in, I avoid typing in negatives. Typing in negatives just is an extra step. So the square root of 7 is not exactly 2.65, but I'm going to write that, 2.65. And then I'll sneak that negative back in there. 8/3. 2.6 repeating. And then what do I got? 53 over 20 gives me 2.65, which I then have to make negative. So here we have a little bit of a problem, and that problem is that we didn't get accurate enough with the square root of 7. So if I still had it in my calculator, I'd recall it if it was a bunch of steps, but I'll just retype it. So here's 6, 4, 5, 7. And now I can see that that can be compared to this number over here. Now I'll be exhaustive with this, and the reason I will be exhaustive with this is to help us see this more clearly. So looking at the most extreme of these, what's the greatest number that's up here? Well, when I compare the two values that are positive, 6,3 repeating would be 6,3, 6,3, 6,3, while this would be 6, 6, 6, 6, 6, 6, 6, on and on. So I know that that's going to have to be 2.6 repeating, and then I'll sneak my comma in there. Now, maybe I choose the lesser of these two values, and the lesser would be the one on the right, so here's negative 2.65, which means that the other negative value would go here, 6, 4, 5, 7, and the other positive value here. But here's the issue. We just did a bunch of rounding, and we rewrote these to help our organization. The final answer needs to be shown the way that they presented these values to us. And the reason I point that out is, well, where did this first value come from? Well, it came from here, which was negative 53 over 20. So when I'm representing this, I should show it the same way that I was presented, because that's what they told us to compare. This is written right above, which makes tracking that a little bit easier. So here's my negative square root of 7. And speaking of tracking, optionally, you might want to cross these out once you're done with them. Don't cross them out incorrectly like I just did on accident. 2.63. And then 2.6 repeating was the 8/3 value that they presented us. There we go. Comparing these with a neighbor, that's going to be a little bit frustrating, and because you guys might approach it slightly different, but it's good exercise because it makes you track things down. All right, do I have another one like this? I don't. So here we go. A few different problems, categorizing, doing all sorts of different things. So I thought it would be nice to break the assignments up to a couple different chunks and make you jump around a little bit so you get a good mix of problems. All right, enjoy.